All right, where we'd left off was we'd gone through all the stuff that explains why we treat the electron as a wave. So remember, the wave-particle duality says that we can treat an electron as a wave or a particle. Heisenberg's uncertainty principle says, well, you can't treat it as a particle. So we treat it as a wave. Then we reviewed Schrodinger, put everything together, came up with a wave equation that describes regions of space where the electron is, or basically is most of the time. We just kind of go, that's where it is, and those are called orbitals, and orbitals are where the electron is everywhere in the orbital at the same time. Then I went through the types of orbitals and the energy levels, and it's very important to keep track that there's energy levels, 1, 2, 3, and so on. Let me just back up to here. No, here, sorry. There. Okay, the energy level, 1, 2, 3, and 4. The sublevels are S, P, D, and F, and then the notation that goes with that. And then remember, going to the next slide, right, that the S sublevel can have 1 orbital, the P's can have 3, the D's can have 5, the F's can have 7, and any orbital can have 2 electrons. Okay, at that point, you should be able to do homework 5. So now moving forward, this is the material that's on homework 6. So just to summarize the notation, if you see notation that looks like this, 2p3, the coefficient is the energy level, that's the number. The letter is the sublevel, and then the superscript is how many electrons. So this would be read as 3 electrons in the p sublevel on the second energy level. We say it 2p3. We don't say 2p cubed. Now, a couple other things before we start figuring out where things are going to go. Orbitals always fill. There's 2 things in an atom that determine where electrons go, and they work against each other. And this is the charge-charge interaction stuff. So to minimize the amount of potential energy, negatives and positives need to be as close together as possible because it takes energy to pull a negative away from a positive. So electrons like to be as close to the nucleus as possible. So we will fill the lowest energy orbital first. Also, electrons want to be as far apart from each other as possible, and we'll talk about that in a slide or 2. This is actually going to be a shorter video. All right, so they always fill from the lowest to the highest energy, as close to the nucleus as possible. Now, we've spread this out, but it gets a little weird. So the 1s is the lowest, then the 2s, then the 2p. Remember that the orbitals within a sublevel have the same energy. Okay, see how the d's are all the same energy and the p's are all the same energy? After the 2p, the 3s, then the 3p, then the 4s, then the 3d before the 4p. Why is that? It works out that way when you do the math. So it gets a little weird. So how are you going to remember this? Before this set of slides is over, I'm going to show you how to get it from the periodic table. And that's the real power that you want to have. But until then, I'm going to show you a little trick. The way to do it is to use this mnemonic device. So you just follow the arrows, think of it like karaoke. So you fill the 1s, then the 2s, then the 2p, then the 3s, then the 3p, then the 4s, then the 3d, 4p, 5s, and so on. All right, I'm going to go through several examples of how to write electron configurations. There's a video within here that you can click on. Okay, now, this is the electrons want to be as far apart as possible. When you're filling degenerate orbitals, so p's, d's, and f's, degenerate means they have more than 1 orbital of the same energy, so the p sublevel has 3 orbitals. What we do is we fill them each singly. So the arrow represents the electron. This is spinning one way. This is spin up, spin down, so 2 different spins. Okay, actually this should only have, there's 1 extra arrow here. My bad. Anyway, we go 1, 1, 1, then we start pairing. We do not pair up and then go. All right, so for our 2p example, the top would be correct. All right, so what I'm going to do, the next slide has a link to another video. And so what you want to do is this video will end, go to the PowerPoint, click on the video, and then watch that. It's 20 minutes long. But I'm going to go through the first 11 atoms on the periodic table, so hydrogen through sodium. For each, I'm going to do 4 things. I'm going to write electron configuration. I'm going to circle what's called the valence. The valence is defined as the outermost energy level. And why is that important? It's important because now we're getting the level of detail that we can say the electrons are on the outside, but we can specifically say which electrons are on the outside and how are they arranged. So the valence configuration is everything in the valence. And remember, the valence is the energy level. The energy level is defined by the coefficient. Okay. Then I'll do an orbital diagram, and the orbital diagram is going to look like this with the arrows. And then we'll do a Lewis dot structure, which is just a shorthand, and we'll use that much later when we do molecular structure. But for now, it's kind of a good place to introduce it. And it's a symbol of the element surrounded by one dot per valence electron. And I'm going to go through 11 atoms, actually more than that, and just see with examples of all of these things. Actually, just the first 11 atoms, I think. All right. So what you want to do now is click on the. So this video is going to end. Then you're going to go back to the PowerPoint, open the slides, click on this. This will take you to a video, a whiteboard video of me doing electron configurations for the electron configurations, circling the valence, orbital diagrams, and Lewis dot structures for the first 11 atoms. It's 20 minutes and 49 seconds long, so I would give myself more time so you can hit pause in the various places and try some for yourself and feel like that you can go back and forth. Give yourself, I'd say, at least a half an hour. All right, I'm going to stop this video here so you can do that. Watch that video, and then you can come back to pick up the last handful of slides here. Have fun with that.